How's everybody doing out there? So hopefully everybody was able to calculate their mean, median, and mode fairly well. And so now I want to talk a little bit more about the skewness that I'd mentioned in the last section. And so what we're going to do is kind of think about it from an algebraic perspective, and then also what it would kind of look like with histograms. So we're not actually going to draw out the histograms, but I got some pictures to demonstrate it with for you. So let's first start off with kind of an extreme example here, just so we can see what skewness looks like. So we've got a small startup company that has one CEO that makes $1 million a year and 9 interns who make $40,000 a year each. So if we wanted to figure out what the average salary is for this company, we would of course take the $1 million that the CEO makes plus 9 times our 40,000, and we're going to divide this all by 10. And so this is going to give us 360,000 all over 10. So this gives us 1360000. Divide by 10, and then when we divide by 10, that's just going to basically eliminate one of these zeros. So this tells us that the average salary of this company is going to be $136,000. But now if we were looking at the median and we lined these up, we'd have, 9 40,000s in a row, and then our 10th salary would be the 1 million. So our median for this company is just going to be 40,000. And so when we look at these, which one do we think is going to be more representative of the actual company and the set of data itself? Well, clearly, the 40,000, since 90% of the employees actually make $40,000, is definitely going to be a better measure of the middle compared to this 136,000. And so again, what happened? What went wrong with this set of data? So the fact that this person makes $1 million would be kind of considered an outlier in this set of data. And so again, like I'd mentioned in the last video, the outliers can really affect the mean and kind of pull it either up or down depending on where our outlier lives. And in this case, our outlier was so big, you can see, look how far away it pulled it. It pulled it 90-some thousand points or dollars up to the right-hand side. So this is pretty extreme. All right, so if we were to kind of see what this data looked like in like a histogram perspective, we would say that the data is actually skewed to the right. And so now we want to be careful because when we look at these pictures, they don't necessarily look like what you might expect skewed right or skewed left to sort of look like. So when we're saying that data is skewed right, it's not talking about where the majority of the data lives. It's kind of talking about where the outlier is, because the outlier is what's skewing that mean to the right or to the left. So when we say data is skewed right, it's more referring to where the outlier lives in relationship. Does the outlier live to the right or does the outlier live to the left? So this is talking about where the outlier, where the outlier lives, or which side the mean is going to get pulled to. So the majority of the data is actually on the opposite side, but we're skewing it means we're moving the mean towards that outlier. So if we look from like a graphing perspective, skewed left, so this means that our outlier is going to live somewhere over here on the left-hand side. And so in that situation, what happens is our mean is going to be less than our median. Now, symmetric just means that it's approximately normal, so there's pretty much no outliers and stuff like that. And when that's the case, the mean and the median are pretty close to each other. They might not be exact, but they're in the ballpark at least. That's the main thing. And then again, skewed right means that our outlier is going to live over here on the right-hand side. And because our outlier is on the right-hand side, our mean has gotten bigger than it should have been, and it got pulled to the right. So very similar to the example that we did up above. So again, it's sometimes tricky to look at the picture because the majority of the graph is over here on these sides. But again, when we're thinking about skewed left or skewed right, we're talking about what's happening to the mean. So the mean's getting skewed to the left, which means the outliers on the left, or the mean's getting skewed to the right, which means the outliers on the right. So it doesn't actually represent, it doesn't talk about the data itself. It's talking about whether the mean is skewed one way or the other. So kind of keep that in mind. But all right, so the green just again gives you a big warning, which I've been mentioning in the last couple of videos, that if there are outliers, the outliers are going to affect the mean. And if that's the case, if you have a choice between mean or median, you want to always choose the median as your measure of center in a situation like that. So, all right, so let's take a look at another example here just to see whether our data looks skewed or symmetric. So we've got our 2010 Winter Olympics gold medal wins by country. So we've got a bunch of lists here. So again, before we can do anything, we need to find the mean and the median of those, and then use the rules that we had above to figure out whether it's skewed left, skewed right, or approximately symmetric. And so again, I'm going to go ahead and go to the calculator where I've typed this in already. So if we go to Stat and Edit, again, I've got all the data already in list 1 ready to go. So if I hit Stat, Calc, 1var stats, and so again I put everything in list 1, hit enter. So I can see my sample mean is 4.25 and my median is 3.5. So let's go ahead and transfer this over to the document. So we've got our mean is 4.25, our median is 3.5. And so again, we're trying to figure out, does this data look approximately symmetric, or does it seem to be skewed one way or the other? And so in this case, what we've got, since our mean is bigger than our median, this means that we've got some outliers that are living to the right. And if you notice, we do have some pretty big numbers, these 10s and 14s and stuff. And so I'd say the 14 is probably the only outlier in this case, because again, the majority of the data is living over in this section. So since our mean is greater than our median, then this means this data is going to be skewed to the right. And again, since our outlier is on the right, that's also another way to think about which way this guy is going to be skewed. All right, so again, these are good things to think about when you're trying to talk about the data. It's another nice way to represent kind of what's going on and see how the mean and the median are related and how the outliers kind of affect what the graph can look like. So go ahead, try these practice problems. So again, we're going back to the same one, so hopefully you have these all in your list, but technically you've already found the mean and the median anyway, so just kind of copy them over from previous sections. And I'll see you in the next video. So good luck. Let me know